tool is likely a Klein tool's twist stripper. It is a T-shaped tool with 4 different size openings for stripping different sizes of wire. The tool uses a twisting motion to strip the wire, and it is made of all metal. The Klein tool's twist stripper is a popular tool among electricians because it is quick and easy to use. It is also very durable, and it can be used to strip a wide range of wire sizes. It's a manually operated tool that simplifies the task of removing the insulation from electrical wires. The twist stripper's design caters to various wire gauges. The operation of the Klein tool's twist stripper is quite straightforward. Select the correct opening that matches the wire gauge you're working with. Insert the wire into the chosen opening. Apply a twisting motion to the tool. This action causes the internal blades to cut and remove the insulation. Pull the wire out and the stripped wire end is ready. The twist stripper offers several advantages over traditional wire stripping methods. Firstly, it provides a consistent strip length, which is crucial for proper connections. Secondly, the risk of nicking or damaging the conductor is significantly reduced. Thirdly, the tool's ergonomic design minimizes hand fatigue, especially during repetitive stripping tasks. The construction materials contribute to the tool's durability. The all-metal build ensures longevity, even under demanding job site conditions. There are considerations when using a twist stripper. Firstly, it's essential to select the correct opening for the wire gauge. Using an incorrect size can lead to improper stripping or damage to the conductor. Secondly, avoid applying excessive force during the twisting motion, as this can also damage the wire. Thirdly, regularly inspect the blades for wear and tear, and replace them as needed. Beyond the Klein tool's model, other manufacturers offer similar twist strippers. These tools often feature variations in design, material, and additional features. Exploring different brands and models can help you find the tool that best suits your specific needs and preferences. While twist strippers are valuable for certain applications, other wire stripping tools are available. Automatic wire strippers, for example, offer even faster stripping speeds and are suitable for high-volume work. Wire stripping pliers combine stripping functionality with cutting and crimping capabilities. The choice of tool depends on the type of work being performed, the volume of wires to be stripped, and personal preferences. Proper wire stripping is crucial for safe and reliable electrical connections. A clean and undamaged conductor ensures proper current flow and minimizes the risk of short circuits or other electrical hazards. Incorrectly stripped wires can lead to loose connections, overheating, and even fires. Always follow best practices for wire stripping, including using the correct tool, selecting the appropriate stripping length, and inspecting the stripped wire for any damage. In addition to manual twist strippers, powered wire stripping machines exist. These machines are designed for high-volume wire processing in industrial or manufacturing settings. They can automatically strip, cut, and even terminate wires with incredible speed and precision. While powered machines offer significant efficiency gains, they are a considerable investment and are typically only justified for large-scale operations. For residential and commercial electricians, manual wire stripping tools remain the most practical and cost-effective option. These tools are portable, versatile, and capable of handling a wide range of wire stripping tasks. Maintaining your wire stripping tools is essential for ensuring their performance and longevity. Regularly clean the blades with a wire brush to remove any debris or residue. Lubricate moving parts with a light oil to prevent corrosion and ensure smooth operation. Store the tools in a dry place to protect them from moisture. With proper care and maintenance, your wire stripping tools will provide years of reliable service. Consider the specific types of wires you'll be working with most frequently. Different types of insulation may require different stripping techniques or tools. For example, some wires have a tough, cross-linked polyethylene insulation that is difficult to strip with standard tools. In such cases, specialized wire strippers with hardened blades or adjustable settings may be necessary. Other wires may have a thin, delicate insulation that requires a more gentle stripping approach to avoid damage. Understanding the properties of different wire types and insulation materials will help you choose the appropriate wire stripping tool and technique for each job. Also, consider the environment where you'll be using the wire stripping tool. If you'll be working in tight spaces, a compact tool with a slim profile may be preferable. If you'll be working in damp or wet conditions, choose a tool with insulated handles to protect against electric shock. If you'll be working outdoors in cold weather, a tool with a comfortable grip may be easier to handle. Selecting a tool that is appropriate for the working environment will improve your safety and efficiency. Many wire stripping tools offer adjustable stripping depths. This feature allows you to precisely control the amount of insulation that is removed from the wire. Adjusting the stripping depth is important for ensuring that the conductor is exposed sufficiently for proper connection, but not so much that it is weakened or damaged. Experiment with different stripping depths on scrap wire to find the optimal setting for each wire gauge and insulation type. Use a wire gauge to accurately determine the size of the wire you're stripping. Wire gauges are available in both Imperial American wire gauge and metric sizes. Using the correct gauge will ensure that you select the appropriate stripping hole on your wire stripping tool. Using the wrong size hole can result in either understripping, where some insulation remains on the conductor, or overstripping, where the conductor is nicked or damaged. Wire gauges are inexpensive and readily available at most electrical supply stores. Always use a wire gauge to confirm the wire size before stripping. After stripping a wire, always inspect the conductor for any damage. Nicks, scratches, or other imperfections can weaken the wire and increase the risk of breakage or failure. If you find any damage, cut off the damaged portion of the wire and re-strip it. If the damage is extensive, replace the entire wire. Never use damaged wire in an electrical connection. Firstly, safety glasses are very important because they protect your eyes from flying debris or insulation fragments. Secondly, insulated gloves will protect your hands from electrical shock. Thirdly, a well-lit work area will allow you to see what you are doing and avoid mistakes. Fourthly, never work on live circuits. Always disconnect the power before stripping wires. Proper lighting, safety glasses, and insulated gloves will help minimize the risk of accidents and injuries. A good understanding of electrical principles is essential for safe and effective wire stripping. Understanding concepts such as voltage, current, resistance, and grounding will help you avoid electrical hazards and ensure that your wiring connections are properly installed. Take the time to learn about electrical safety and best practices. There are many resources available, including books, articles, online courses, and training programs. The National Electrical Code, or NEC, is a comprehensive set of standards for electrical wiring and installation. The NEC is updated every 3 years and provides detailed guidelines for all aspects of electrical work, including wire stripping. Familiarize yourself with the NEC and follow its requirements when stripping wires. The NEC is available for purchase from the National Fire Protection Association, or NFPA, and is also often available at local libraries or online. Proper documentation is an important part of any electrical project. Keep records of all wiring installations, including wire sizes, stripping lengths, and connection methods. This documentation can be helpful for troubleshooting problems in the future and for ensuring that the electrical system is properly maintained. Use wire connectors that are appropriate for the wire size and type. Wire connectors are designed to create a secure and reliable electrical connection. Using the wrong type of connector can result in loose connections, overheating, and even fires. Follow the manufacturer's instructions when installing wire connectors. There are numerous types of wire connectors available, including twist-on connectors, push-in connectors, and crimp connectors. Each type of connector has its own advantages and disadvantages. Choose the connector that is best suited for the specific application. Regularly inspect your wiring connections for any signs of problems. Look for loose wires, corroded connections, or damaged insulation. If you find any problems, repair them immediately. Regular inspection and maintenance can help prevent electrical hazards and ensure that your electrical system is operating safely and efficiently. When working with aluminum wire, it is important to use special connectors and techniques. Aluminum wire expands and contracts more than copper wire, which can lead to loose connections over time. Use connectors that are specifically designed for use with aluminum wire. These connectors are often filled with a special compound that helps prevent corrosion and maintain a tight connection. Also, when connecting aluminum wire to copper wire, use a transition connector that is designed to prevent galvanic corrosion. This is crucial for preventing premature failure of the electrical connection. Galvanic corrosion occurs when two dissimilar metals are in contact in the presence of an electrolyte, such as moisture. The electrolyte causes one metal to corrode more rapidly than the other. Transition connectors are designed to isolate the two metals and prevent galvanic corrosion. Some wire stripping tools have built-in wire cutters. This feature can be convenient for cutting wires to length before stripping them. However, it is important to use a sharp wire cutter to avoid damaging the wire. A dull wire cutter can crush or deform the wire, which can make it difficult to strip properly. If your wire stripping tool does not have a built-in wire cutter, use a separate pair of wire cutters. The quality of the wire stripping tool can affect its performance and durability. Invest in a high-quality wire stripping tool from a reputable manufacturer. A well-made tool will be more precise, easier to use, and longer lasting. Avoid cheap, low-quality tools, as they may not strip wires properly and may break easily. Consider the warranty offered by the manufacturer. A good warranty will protect you against defects in materials or workmanship. Some wire stripping tools have replaceable blades. This is a convenient feature, as it allows you to replace the blades when they become dull or damaged. Replaceable blades can extend the life of your wire stripping tool and save you money in the long run. When replacing the blades, be sure to use the correct type of blades for your tool. Some wire stripping tools have adjustable blade depths. This feature allows you to adjust the depth of the blades to match the thickness of the insulation. Adjustable blade depths can be useful for stripping wires with different types of insulation. Some wire stripping tools have a built-in wire gauge. This feature allows you to quickly and easily determine the size of the wire you are stripping. A built-in wire gauge can save you time and effort. Some wire stripping tools have a built-in ruler. This feature allows you to accurately measure the length of the wire you are stripping. A built-in ruler can be useful for ensuring that the wire is stripped to the correct length.